start the next chapter, which is going to begin with 2.1.1. So we're looking at graphs as solution sets and function notation. So the first one says graph the solution set for the linear equation negative 3x plus y equals negative 2. So the first thing let's talk about is what's a solution set? Well, that's just all ordered pairs that satisfy an equation. So all x values and all y values, that when you plug them into the equation, that it would give you a true statement. So if I look at this function, it says negative 3x plus y equals negative 2. It says step 1, let's solve for y. So if I solve for y, I'm going to add 3x to both sides. So you would get y equals, remember the right-hand side, they are not like terms. So we're going to rewrite them as 3x minus 2. So step 2 says we're going to make a table and choose at least 3 values for x and find the corresponding y values given the equation. So I'm going to say, okay, if this is x and this is y, I'm just going to pick a good sampling of numbers. So if you look at this equation, it's going to be good to have some negative values and some positive values. So I'm going to pick negative 2, negative 1, 0, 1, and 2. It said at least 3 values, but I feel like if you do these 5 values, you'll get a good picture of what this function looks like. So we are going to have to figure out what's the corresponding y. So let's plug in negative 2 for x. So this would become 3 times negative 2 minus 2. Well, that would give us negative 6 minus 2, so that would be negative 8. Could you use your graphing calculator to access the table function in order to figure out this table? Absolutely. But if you don't have your graphing calculator, you can do this by hand. So let's plug in negative 1 for x. So 3 times negative 1 minus 2. Well, that's negative 3 minus 2. So we would get negative 5. All right, if you plug in 0 for x, 3 times 0 minus 2. Well, 3 times 0 is 0. Minus 2 would be negative 2. 3 times 1 minus 2. Well, 3 times 1 is 3. Minus 2, that would give me 1. And then the last one says 2, so let's plug in 3 times 2 minus 2. So that's 6 minus 2, which is 4. So we have 5 sets of ordered pairs. So when you plugged in negative 2, you got out negative 8. When you plugged in negative 1, you got out negative 5. 0 as an input gave us negative 2 as an output. Plugged in positive 1, we get out positive 1, and 2, we get out 4. So it says for step 3, we just want to plot these ordered pairs on the coordinate plane. So negative 2, negative 8. Negative 1, negative 5, so to the left 1, down 5. 0, negative 2, to the right 1, up 1, and then 2, 4. So all I have to do now is connect my dots with the straight line, and we're going to want to extend this line the entire length of the graph. So that's my final equation. So if I'm looking, what are the solution sets for this linear equation? It's any point that is on the line. So are the points that we have the only ones? No, we could have, if I look, there are more points. This would be a solution right here. This would be a solution. So there are many solutions to this equation. All right, let's look at the next example. So number 2 says graph the solution for the equation y equals 3x. So hopefully you're thinking this is an exponential function. So we're going to make a table. Remember, exponential functions, you need a table of values in order to graph it. So let's pick, again, some good values. Let's pick -2, -1, 0, 1, 2. All right, so if you plug in -2, 3 to the -2nd power is going to be equal to 1/9, which is around, if you use your calculator, 0.1. So if you plug in 3 to the -1st power, that will give you 1/3, which is approximately 0.3 repeating. 1/9 is 0.1 repeating. And then if you plug in 0, what's anything to the 0 power? 1. And then 3 to the 1st power, we would get 3. And 3 squared is 9. Remember, you could use your graphing calculator by typing that into the y equals and accessing the table. All right, let's draw an x and y axis here. So if I look at my table of values, remember there's going to be no negative y values here. So I'm going to just make my x-axis here and my y-axis here. So to the right, I'm just going to label it by ones. 2, 3, 4, 5, 6, 7, 8, 9. So this would be -1, -2. If you need to pause the video at any time to write this graph, do so. All right, for the ones, for the y's, I'm going to just go up by ones as well. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then if I kind of go in the other direction, I would have room for -1 and -2. All right, so let's plot these as ordered pairs. So it looks like at -2, you plug in -2, and you get out 0.1. I'm going to write this on the other side. So when we plugged in -2, we got out 0.1 repeating. When we plugged in -1, we got out 0.3 repeating. When you plugged in 0, you get out 1. When you plug in 1, you get out 3. And 2, you get out 9. All right, so let's graph this. The first order pair is -2 and then 0.1. So I'm going to go to the left 2, and then 0.1 is just going to be above that x-axis. -1 and then 0.3. So to the left, -1, 0.3 would be in between 0 and 1 there. 0, 1. So I'm going to go up to 1 on the y-axis. 1, 3. We're going to go to the right 1, up 3. And 2, 9. So to the right 2, all the way up to 9. So remember, this is an exponential function because I have an exponent as a variable. So I'm going to connect the points in a curve. The points, the line will never cross the x-axis. You will never have negative values. So if you look, I'm going to connect to the left so it gets close to the x-axis but doesn't cross it. And I'm going to do the same above. I'm going to connect it, and we can draw an arrow on the end because this is going to continue on exponentially. So that is our solution set for the equation y equals 3 to the x power. So again, are these the only ordered pairs that would be solutions? No, this just gives a representation of what some of the solutions are for y equals 3 to the x. All right, so the last one is a word problem. So it says the Russell family is driving 1,000 miles to the beach for their summer vacation. Mr. Russell drives at an average rate of 60 miles per hour and plans on stopping 4 times to break up the journey. Let T represent the number of hours the Russells will travel before they reach their destination, and D be the remaining distance after each stop. Write an equation in terms of D and T that represents a 1,000-mile trip, and then it says next, draw a graph that represents the number of miles traveled for each hour of the trip. All right, so the first thing we're going to do is we're going to come up with an equation that represents the situation. So write the equation in terms of D and T that represents a 1,000-mile trip. All right, let's highlight all of the numbers. So you have 1,000, 60, and it looks like that's it. So what's important to highlight next to 1,000? So that's our miles. And then 60 miles per hour. We don't know the time, so that would just remain T. So hopefully you know that distance equals rate times time. So I'm going to plug in 1,000 for the distance. Your rate is 60 miles per hour, and you don't know the time. So that would be T. So if I get all of the terms to one side, so let's subtract 60T. The distance remaining, so I'm going to use a capital D, is going to equal what we started off with, 1,000 minus 60T. Because if I'm traveling 60 miles per hour, after 1 hour we traveled 60 miles. After 2 hours we traveled 120, and so on. So this just represents the remaining distance. All right, so if you look at this function, we want to be able to graph it. So we want it to look like our typical y equals mx plus b. Well, if it's y equals mx plus b, in this equation, what would the slope be? Well, do you see how it says minus 60t? That means that we are going to make it y equals negative 60x, right? The variable now would change into x, which is something we're more comfortable with graphing. And then the intercept, the y-intercept is that constant term, so that would be plus 1,000. All right, so now we have to label our graph. So if I look at the bottom, the x-axis, that's going to be the time in hours. And the y-axis is going to be the distance remaining in miles. All right, so now that we have our labels here, let me get this a little bit tighter. Okay, so we have to figure out what would be an appropriate scale. Well, hopefully you're thinking for time we could just go by ones. I'm just going to write every odd number. So 1, and then that would be 2. And then this would be 3, 4, 5. Oh, it made it a circle. Let me fix that. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, there's 20. Last one on this, it would be 21. All right. So now we have to think about what's an appropriate scale for the time remaining, the distance remaining, excuse me. So if you look, we're going to have to kind of make a table of values to see what would be appropriate for this function. So let's make an XY chart. So if you plug in 0, what would your output be? Well, use the table of values on your graphing calculator and type in this function. Type in negative 60x plus 1,000. Type that into your y equals. So if you look at the table of values, 0 is going to give you 1,000. If you did 2, it would give you 880. If you looked at 10, it would give you 400. What about 17? That would give you 0. So would I need to use values greater than 17? Well, hopefully you're thinking we would never have negative distance. So that would be the end of the trip at the 17th hour there. So we would stop there at 17. So let's graph these. Let's go ahead and plot our y-axis here. So I need values from 1,000 to 0. I'm going to go by 50s. So I'm going to say each grid line is 50. So 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. So halfway there, 550, 600, 650, 700. Remember, you can pause the video if you need to write your scale. So I'm at 850. Here I get 900, 950. So all the way up top is exactly 1,000. All right, I'm just going to kind of make the X and Y axis a little darker on this so we can kind of see what's happening. So I'm just going to highlight the bottom X axis and the vertical Y axis. All right, let's plot these points. So the first point is 0, 1,000. So if I go to the right, or if I go to 0, 1,000, I'm going to be directly on that y-axis at 1,000. So that's my starting point at 0, 1,000. 2 is 880. So you just kind of have to estimate to the right 2, 880 would be a little bit more than halfway between 850 and 900. 10 is 400. And then 17 is 0. So if I connect my dots here in a straight line, that would be my final answer. So how long was the trip that the Russells took? It was 17 hours long. All right, so make sure that you take a picture of your notes and submit it to Google Classroom. Have a good